ये मतलब जी सर, नहीं सर, नहीं।
ताकि क्वेश्चन पूछने वालों को टाइम दे सके। ठीक है, तो बेसिकली जो भी टाइमर मेंटेन कर रहा है वो 8 मिनट पे एक बेल बजा दें, अकॉर्डिंगली हम लोग प्रोसीड करेंगे। तो फर्स्ट प्रेजेंटर इज गवर्नमेंट कॉलेज ऊना से आप लोग? इधर ये अलग है क्या? वही मैं पूछ रहा हूँ, गवर्नमेंट कॉलेज ऊना लिखा है। गवर्नमेंट कॉलेज ऊना से है बेटा? तन्नू, तन्नू कौन है? तन्नू ये, अच्छा आप एंकर हैं। हाँ ठीक है, ठीक है। ऑनलाइन पार्टिसिपेंट जुड़े हुए हैं। हाँ इससे अंदर भी है। सभी आवाज चली जाएगी सर। आई एम हर्ष शर्मा। My name is Monica of Government Hydro Engineering College. And we are your host for this session. So, we are glad and delighted to announce that Professor Deepak Bansal, Director cum Principal, Rajiv Gandhi Government Engineering College, Nagrota, has graciously accepted our invitation to be the chairperson for this session. Professor Deepak Bansal brings a wealth of knowledge and experience in civil engineering. He has, to his credit, B.Tech in Civil Engineering, ME in Construction Technology and Management, and a PhD in Energy and Environmental Engineering with flying colors. His area of specialization include concrete technology, renewable energy, and sustainable development. We are truly honored to have you lead this session and guide us through the insightful decisions ahead. Your presence will undoubtedly add tremendous value to our conference. Now, with great pleasure, let's extend a warm welcome to Professor Deepak Bansal.
But before we start, there is one rule to the presentation. The maximum time given for each oral presentation is 10 minutes. However, the bell will rung after 8 minutes in order to remind the speaker. So all the speakers are requested to be please stick to time the duration. So without any further delay, let's invite our first presenter, that is Ms. Tanu Sharma, Mr. Love Jaswal, Ms. Rajni Sharma from Government College, Pune, presenting Interconnected World, reviewing the evolution and applications of IoT.
So very good afternoon to all the guests present in this international conference. Myself, am I audible?
Yes, yes, ma'am.
Okay. Thank you so much, sir. First of all, I want to start my presentation on the paper titled Interconnecting Word, Reviewing. Let me first share my content. Sir, is this visible?
Yes, ma'am.
So, my presentation on interconnected word, reviewing the evolution and applications of IoT. As we are dealing with
Slide
IoT,
show में चले जाइए।
slideshow, sir, I have done already.
It is not there.
मैम एक ऑप्शन होगा फ्रॉम बिगनिंग, उस पे क्लिक कीजिए प्लीज।
Wait, wait, sir. So now is it?
नो मैम स्क्रीन शेयर ऑफ हो गया आपके।
Oh, wait, sir, wait.
हाँ सर।
Is it, sir, visible now?
यस मैम, आप इसको एक बार स्लाइड शो में ऐड कर दीजिए, वहां पे ऊपर फाइल्स के नीचे ऑप्शन फ्रॉम बिगनिंग, उस पे क्लिक कीजिए प्लीज।
So that is I have done already. Wait, sir, wait. So let me start first. So is it visible now?
नो मैम।
Now?
यस मैम।
स्लाइड शो नहीं करना आता है।
So wait.
रखा था उसी उसी फॉर्मेट में कर दीजिए please. Visible now.
मैम का माइक म्यूट किया है ना आपने, अनम्यूट करो उसको।
उन्होंने खुद ही
तो आप भी कर सकते हो।
Am I audible?
यस प्लीज।
Uh, Now, sir, is it visible?
Yes, ma'am.
So, interconnected world, reviewing the evolution and applications of IoT. So let me start now.
Yes, ma'am.
So can I start now?
Yes, ma'am.
So IoT, as my presentation is on evolution and applications of IoT. First of all, I want to start with the basic definition of IoT. That IoT is basically network of interrelated devices that connect and exchange data with other IoT devices and cloud. And if we talk about the connected devices, or if we talk about the various IoT devices in India, so that is approximately 5 billion connected devices in India. This is the research study of up to 2023. And this number will increase up to 50 billion by 2030 if we are talking about the India connect IoT connected devices. And if we talk about the basic structure or how IoT works, so that IoT working is basically deals with the sensors, softwares, and different technologies. If we are talking about the sensors, so that sensors means that sensors means from where we are going to get the data. That data we are going to send to the cloud, and basically our main fundamental is related with these sensors, and that sensors collect the data from any of the things. Like here the term is internet of things, means that thing is connected to the internet, and from that things, with the help of sensor, we are getting the data, or we are getting the signal. And the actual task of the sensor is to convert the one form of signal to another signal. And then the terms related to big data, fog computing, all came into existence. So this is my fundamental presentation on basically that what is IoT. And if we are talking about history of IoT, so history of IoT begins from 1989. And if we are talking about the basic history of IoT, so in 1999, Kevin Ashton, he first coined the concept of IoT. In that concept, he conducted his research on the items using the internet to build a communication bridge between the devices and the modern world.
Tanu, sorry to interrupt. You are on which slide?
Sir, I am on history only, second slide, third slide, I think.
You're on third slide. We can't be your third slide. Na? Here it is being shown that you are on the first slide.
Okay, sir.
And
Sir, is it now visible?
It is visible, and make sure that you finish your PPT within prescribed time.
Okay, sir. Okay. Actually, sir, due to connectivity and all, I started late, na? That's why. Then after that, sir, now can I start fast, na?
Continue.
Yes, sir. Thank you. Then after that, if we talk about the Kevin Ashton, then so on up to 2022. Now IoT is becoming world economic form, and many devices are connected to the internet. And due to the inventions in the ICT and all, everything is connected to the internet. Anything, if we talk about smart city concept, smart health, smart home concept, all came into existence. And literature review, I have reviewed many of the papers, but I have mentioned only few. That in many of the papers, they were like in the first paper, they were going through the existing IoT methodologies. And then after that, I have gone through the one paper that is energy, that was related to the research, 10 research topics in IoT. Then after that, Mandeep Kaur, in this paper, they were focusing on the fog computing nodes and all. Then after that, evolution of IoT. Then evolution of IoT is basically, if we talk about IoT evolution, IoT started from pre-internet concept. Then in that only we were fixed up to the fixed mobility and SMS only. Then after that, internet of content came into existence. Then web 2.0 is there. Then social media came into existence, that is Skype and all. Then machine to machine interaction, if we talk about the smart city, smart home, and smart agriculture, any of the concept that is related to the internet, we are going to provide the data through the sensors, and that data is we are going to store in the particular at the particular cloud server, so that easily we can access each and everything according to our needs. Then IoT, another names to IoT is machine to machine communication or machine to machine interaction, internet of everything. Fog computing is also there, and another name also edge computing. Then smarter planet is also becoming, means because of the internet connectivity, everything is becoming smart. And then industrial revolution or industrial internet is also there. Especially how IoT works, first of all, the first basic concept I have discussed earlier also, that mainly the sensors started. With the help of sensors only, we are going to get the data that we are going to connect to the internet. And that sensors functionality is converting the one form of data to another, and then we are connecting, we are sending that data to the cloud infrastructure, and that sensors should be connected to the cloud using various mediums. And after that, we are having the various communication also, data processing also, and user interface also, from where either through the link or through the message we are going to get the information about that particular IoT device. Then growth of connected devices is also going to increase up to million by 2030. So number of connected devices are increasing, and IoT applications are also there. If we are talking about IoT applications, connected cars are there, smart homes are there, parking sensors are there, connect health is there, and smart cities also there. If we talk about the smart city, then we are talking about the smart transport is also there, smart environment is also there, smart agriculture, smart industry, or smart society, smart energy, smart healthcare is there. So means everything, like if we are talking about smart home, like when we enter, our car enters the passage of our home, automatically lights will turn on, automatically the door will open, automatically the coffee making machine will start making the coffee for us. So this is the concept that I want to discuss, and this is all from my side, sir. Thank you so much, sir.
Thank you so much, ma'am.
Thank you so much, sir.
Questions allowed hai? Yes. Any question from audience? Chalo, thank you, ma'am. Next speaker.
Thank you so much, sir.
Moving on, we have Mr. Rohit Verma from NIT Hamirpur, presenting on the topic utilizing machine learning for optional positioning and seizing of distributed generation.
Hello, am I audible?
Yes.
Okay, I am now presenting my screen. My screen is visible.
Yes.
Okay, first of all, good afternoon, everyone. My name is Rohit Verma. I am a student of MTech Power System at NIT Hamirpur. I am here to present my paper titled Utilizing Machine Learning for Optimal Positioning and Sizing of Distributed Generation. So the basic outline of my presentation is the introductory part, then the problem formulation, the methodology, the results, comparison graphs, conclusion, and the future work and recommendations which I have given. First of all, the introductory part. Nowadays, there are certain challenges in the energy field, the growing demand for the energy, the need for energy efficiency, and the reliability of the system for our distribution and transmission. So, distributed generation can be a strategic solution to address these challenges. Sources like solar, wind, etc., can be placed at the load end to meet these requirements, but due to the high resistance by reactance ratio or other factors of the system, it is difficult for us to integrate DG distributed generation directly into the system, which can weaken the bus voltage profile of the system and hence can increase the losses of the system also. So by proper placing my solar plant or windmill or any other plant which I am going to place, it need a deep study about the conditions or the proper size and placement strategy on which bus or at which place it should be placed, which can reduce the distribution losses, the can improve the bus voltage profile of the system, and hence can increase the system stability and transmission reliability margins. So, first of all, what are the distributed generation? Distributed generation are energy resources, fuel cells, photovoltaic arrays, wind turbines, gasifiers, geothermal energy plants, micro hydro generator, or any other type of like batteries, which can be placed at the load end where our requirement is, which can be used as a standalone plant, which is required when we need it, then the standby plant as a remote application or for peak load shaving. Uh, the size of the DG and the structure can determine how much power it can generate. Like we have different solar panels connected in series or parallel combination can decide its generation, which is important as per our the system requirements. And this can minimize distribution losses and hence improve the voltage profile when placed optimally at the best location. So the various challenges in distribution generation placement is that the if we apply multiple distributed generation at certain random places, it can produce potential disturbances in the system. So for optimally placing the system, the DG in the system, we have to consider like power losses, the load factor of the system, the voltage profile, the generation and transmission cost, which is the main that how much cost our plant will uh, occur when we place it at the load end. Various strategies already been put forth for this problem, like computational or analytical random injection already been proposed. So, but it need require a more data driven solution for this problem nowadays as per the requirement. So the my proposed solution for the in this paper is the machine learning technique, that is a decision tree regression with combination of the particle swarm optimization technique to improve the accuracy and effectiveness for DG placement. Here in the paper, I have discussed about the 33 bus radial distribution network system. First of all, the decision tree regressor, it is a supervised machine learning technique which is trained on labeled data set, which is predefined data I have given from the system, from various sites or the loads I have taken from internet, and then I have given the basically I have done it for to reduce losses. The goal is given, then as per that goal my model is being trained in the machine learning algorithm. And for this process I have involved the feature extraction from online databases, and then the load flow analysis is being done. Then model, the machine learning model, the decision tree regressor is being trained, and then the placement of DG is being done. So this is the problem formulation for my paper. That is, the objective function is basically to reduce the losses. The losses here is given by the scale of branch current into the resistances of the branches, subjected to different constraints like the DG constraint. The DG constraint I have applied is the size. Like if I have to place a solar or wind, or it should lie between the size 200 to 400, 4600 kilowatt, not more than and not less than this. This is the limit I have applied in the code. Then the power balance constraint. The power balance constraint means that without that the initial stage when there is no source connected, the power at the substation we are getting is able to supply the load plus the losses of the system. But now as we add a DG, will it be, it will it disturb the power balance of the system or not? It should be maintained at equilibrium. And the voltage constraint, the voltage constraint is a main aspect in the system. I have taken the voltage per unit limit in as 0.9 to 1.08 in the calculation of the system. As I have already told in the objective function that the I branch is the current in branches and the Ri is the resistance of the branches connected in the system. So the significance of the constraints is basically the DG size is to control the DG power output of the system, which we have going to connect. And then the power balance, as I've already told, to maintain the system equilibrium, and the voltage constraint to ensure acceptable voltage level in the system. Then the methodology, that how I have done this whole process in the system. So the first step is the load flow analysis. Firstly, we have to calculate the losses. Then the next step is to utilize the machine learning into the system. But first of all, I have done the load flow analysis without any source connected in the system by using a forward backward sweep algorithm. Here I have calculated the basic base voltage profile of the system, the branch currents of the system, the power flow in the system, and the total losses of the system. For this, I have given the line data, the load data connected in the system, and then I have used the DTR to train the model for suitable installation in the 33 bus system. Employed then PSO for size. Now size is also required. So for sizing, I have used DG PSO in the system, which is aimed to give a size between 200 to 400, 1000 and 600 kilowatt in the system in the load flow for reducing losses. So I have basically done this whole work on Python using the sklearn module in the system to reduce losses. I have applied a solar photovoltaic system. The first is the generation I have taken, then the load I have taken of the system. Then the first, I have done it in two cases. The first case is without DG, then I have certain findings of the system, like the losses I have calculated in the system as you are showing on the screen. Then I have also identified buses with the minimum voltage for further calculation, but I have also mentioned it here. Then the instance with DG, when the solar PV of module size, this size on the screen is placed on the system, then I got less losses as compared to the initial case in the system, which is 39.323% less than the initial case, which is a clear demonstration that my technique is clearly effective as I have compared to also the another also techniques in the system. These are basically the graphs that we can see that the voltage profile in the system has been increased. The light green one is the upgraded, is the improved voltage. Then the branch currents also has improved. The real power flow, and the losses, the light green line in the losses section is reduced, which means my algorithm is working correctly here. So with basically the conclusion is here, the placement of the DG to improve voltage profile and reduce the losses. Significant decrease shows the effectiveness. This is a foundation for power system for enhancing network performance. So the future recommendations can be to add cost minimization. I have not included cost in it. I can place of any cost like costly or less costly, but here I can also add a cost minimization factor, stability, reliability, or maximization. Further, integration of advanced algorithm of artificial intelligence can use prediction. The study can further investigate to aim the placement of distributed generation for optimization for the scope of good and refined distribution power network. Thank you very much.
Any question from the audience? Rohit, your losses depends on two factors, your current and your resistance. So how you are reducing losses? You're reducing resistance or you're reducing current?
Reducing current, sir. I am reducing the current of the system.
Current of the system basically means like you are adding power from DG sources instead of you are actually compensating the power from the
Yes,
with the help of the DG sources instead
yes,
of getting the power from the main grid.
yes, sir.
You are reducing the power from the main grid.
Yes, sir.
So you mean to say that when you will be having one line which is going from DG sources to load end, that will be having less current or less resistance compared to the line which is coming from the main grid to the load. Is it like that?
Yes, sir, it is like that, but my algorithm is directly predicting on the data I have given that the initial resistances and the current firstly calculated.
Resistance will remain fixed.
Yes, sir. Yes,
And
sir.
the amount of power you
Current.
need at the load, that will decide the value of current. That will also be fixed one if you are having fixed voltage levels.
Yes, sir.
So how you are reducing current?
Basically, sir, the current from the grid is constant. That is, I am not means मैं उससे कोई छेड़छाड़ नहीं कर रहा हूँ. But the at the bus where I have placed the DG, from there the rest current is been supplied, which will reduce the losses, sir.
Okay. The DG supplying rest of the power.
Yes, sir.
If you will take that rest of the power from the main grid instead of DG, the losses will be more.
Yes, sir. The current will be more because of the from the grid.
Current will remain the same. Sir. If the power level is having 100 watt and we are having 10 volt, the current will remain same 10 ampere in case of DG also and in case of your main grid also.
Yes, sir. Yes, sir.
And your load side is your DC or AC?
The load side is AC, sir.
AC, na? So you are converting that power to AC also, na?
Yes.
Your solar power.
Yes, sir.
The DG source that you have used.
Yes, sir. Yes, sir.
You're converting it to AC, though that skin effect, Ferranti effect will again come into picture.
Yes, sir. Yes, sir.
That losses will also be there, na?
Yes,
so
sir,
how you are omitting, how you are reducing the losses? I mean to say that.
Yes, sir. Yes, I am reducing the losses. I am improving the voltage profile also.
Okay. Okay.
Yes, sir.
There is small observation in your presentation.
Yes, sir.
Am I audible?
Yes, sir. Yes, sir.
Like you are using capital K in kilowatt. It should be K should be small.
Okay, sir. Okay.
Small observation.
Yes, sir.
Okay, thank you.
Okay, thank you, sir.
Next speaker.
गुड इवनिंग एवरीवन. पार्टिसिपेंट्स के लिए एक अनाउंसमेंट है कि अगर OP9 से लेके OP16 तक किसी ने यहाँ पे ज्वाइन किया तो वो काइंडली दूसरा लिंक ज्वाइन कर दे. OP9 को OP16 का लिंक ये नहीं है. थैंक यू.
Thank you, sir. So Our next presenter is Mr. Bhupinder Kumar from Sholini University, presenting application of machine learning algorithm to assess concrete strength with coal ash integration.
I hope my voice is audible.
Yes.
Okay, let me first share my screen. यहाँ से ऑडियो बंद कर सकते हैं, कुछ बात करनी है तो। अच्छा सर, ये वैसे ये भी ये, हाँ, ये दबा दीजिए वैसा। I hope my screen is visible to everyone.
It is visible.
Okay, thank you. So, first of all, good afternoon, everyone. My name is Bhupender Kumar, and I'm a research scholar. And my topic is application of machine learning algorithms to assess concrete strength with coal ash integration. These are the outlines in my presentation, where I'll be first discussing about the introductory part, then machine learning, methodology, novelty, result, and then the conclusion section. The first of all, introduction part of this presentation. Concrete, which is widely used globally for constructing structures, and concrete is, and this is we can say the second most widely used construction material after water. And the process of this creating cement concrete, it involves blending various components like aggregate, water, cement, and some admixtures, occasionally reusing by products or recycled demolition material. Unfortunately, the production of these concrete and its source material, it demand significant energy, resulting in substantial CO2 emission, carbon dioxide emission, that contribute to environmental pollution and greenhouse gas emission. Further, the ongoing reliance on this raw material, such as coarse aggregate, fine aggregate, cement, as well as some additives, put strain on natural resources and intensifies this environmental impact. So, several options have been identified and categorized as potential alternatives to traditional construction materials. What are these materials? There are many materials. There are some fibers, there are some waste plastics which are being used to recycle, and these include like treated aggregate from demolished concrete, discarded plastic, glass waste, rubber waste, some scraps, as well as organic and agriculture residues. Waste material can serve various role in concrete, including acting as replacement. It can be fully or it can be partially for cement or aggregates, as well as filler or fibers. Given that cement production poses environmental concern, waste material can be uh, it can be valuable substitute for both of these cement as well as the aggregates. The environmental benefits of utilizing these waste material in place of cement can be explained through different parameters. In this current study, we have used this coal ash material, which is a byproduct also, and it is a waste product from coal-fired power plants that contain contaminants like mercury, cadmium, and arsenic. It is usually disposed of in landfills or surface impoundments, which can pose environmental and health risk. It has some pozzolanic properties, meaning that it reacts with calcium hydroxide from cement hydration to form calcium silicate hydrates, which is CSH gel, which are the main binding agent. This is the reason that we are using this coal ash as a cement replacement. And here are some key reasons why it is being utilized because of waste utilization. It, as I earlier said, that it has some pozzolanic properties, also some economic benefits, as it is a waste product. So we there will be two benefits. One, it will be utilized, and as I earlier also said, that it has some environmental issues, so it can be recycled. And third, and the last is reduced carbon footprints. Next is the machine learning techniques. Various soft computing techniques have been used in this, and these soft computing techniques, it play a significant role in optimizing and enhancing the concrete performance, especially when incorporating in this current research by using this coal ash. As I earlier said, that this is a byproduct of coal combustion, which has increasingly utilized in concrete production due to its pozzolanic properties, which can contribute to improve the durability and sustainability. And because of these soft computing, such as there are various computing techniques like artificial neural network, which is ANN, genetic algorithms, fuzzy logic, random forest, random tree, SVM, etc. So, for the current study, we have used three, which will be discussed in the coming slide. These are ANN, RT, and one another techniques. Before going to that, first discuss about this objectives. There are three main objectives of this study. The first is to investigate the viability of employing machine learning technique to accurately forecast the compressive strength of concrete mix. This is the first objective where we will be applying this machine learning, or I can say these soft computing techniques. The second is to establish a reliable model. So, based upon these techniques, that these we can go for the past literature, where we will get to know that among various techniques, which techniques are the best for this particular material, and to establish a reliable model based upon those techniques that could anticipate the resulting compressive strength of concrete blends incorporating coal ash. And the last will be to improve the performance characteristics of concrete, such as strength, durability, and resistance to chemical attack. This is the methodology of this current research work. The first, the data has been collected from the past published literature. Otherwise, it can be collected from the experimental work. But for this current study, it has been collected from the published literature. Then that data which has been collected from the literature was separated into the training and testing in the proportion 70 into 30, 70 by 30. Otherwise, it's completely up to the user that in what proportion user wants to separate that data. Randomization will be there based upon the analysis, and based upon those results, it will be the user will decide that how accurate will be that proportioning of this. Then model selection, for the current study, ART, ANN, and RF are the model which have been selected, and based upon certain evaluation parameter like CC, MAE, RMSE. These have been this complete analysis have been evaluated based upon this. Then based upon this, the best model has been finalized. First, then is the novelty. What is the novelty about the CSH gel? I have already discussed in my previous slide. So directly coming to the result part, this is the performance matrices for ANN, RT, and RF models. This is showing the result section for the training as well as the testing data set. And from this testing data, the CC value is coming higher to this ANN model. So we can say that this ANN model, it emerges the most promising among the various models which have been used in this study. And to assess the model's predictive abilities, as I said, that these CCME and RMSC have been used for the evaluation parameter, and these are the results. The performance evaluation of each model was executed through various matrices, including CCME and RMSE. These matrices served as a crucial indicator in the selection of the model, in the selection of the most suitable model. And higher CC value and lower error values indicate superior outcome. Numerous studies have previously identified optimal setting of for the different techniques, and the parameter setting utilized in this study proved to be ideal for both the training as well as the testing data set, ensuring robust performance outcomes. And from this figure provides visual representation illustrating the correspondence between actual as well as the predicted values for both the training as well as the testing data set using this ANN, RF, and RT. This is the comparison of all the models which have been applied in this, and this graphical representation demonstrates that the majority of the data points, the majority of these data points closely align with the line of perfect agreement, highlighting the model's notable predictive accuracy. And in comparison to all the other models, the ANN models outperformed distinguishedly. And in the conclusion section, as I already discussed about the results section, that the ANN model is coming the best, and this is from the analysis, and also the sensitivity analysis has been done for the current study, where we eliminate one parameter at a time, and at that time that for this from among the various input parameter like cement, sand, aggregate. So for this current study, cement has come out to be the best input parameter for predicting the compressive strength of this particular material. So it's all from my side. Thank you.
भूपेंद्र जी, दो क्वेश्चन है मेरे, या ऑब्जर्वेशन बोल सकते हैं.
हाँ जी सर.
एक तो जो जनरली हम लोग टर्म यूज करते हैं वो फ्लाई ऐश यूज कर सकते हैं, कोल ऐश नहीं यूज करते हैं आमतौर पे. तो व्हाई आर यू यूजिंग द टर्म कोल ऐश ओनली, नॉट फ्लाई ऐश?
Actually, sir, I have gone through the various research articles, and there the authors are using this term. So is the reason that I have chosen this term also. Otherwise, your question is valid. That there, I have also gone through the various research articles which have used the term fly ash.
तो मेरे ख्याल से आप अपनी गाइड से डिस्कस कर सकते हैं कि कैन यू रिप्लेस कोल ऐश विद द फ्लाई ऐश इन योर.
Sure, sir. Okay, sir.
Then next, in your objectives, you are using concrete mixtures, then concrete blends. Are these both same or different?
These are different, sir.
If these are different, then it's all right. लेकिन अगर ये दोनों सेम है तो आप लोगों को फिर एक ही टर्म यूज करनी चाहिए.
Okay, sir. If it is same, then we'll use the single term. Otherwise, from my point of view, the term is different.
How it is different? Can you explain difference? Objective number 1 and 2 in your presentation.
Objective, you are asking about the objective, sir.
In objective 1, you have used the term mixtures, and objective number 2, you have used the term blends.
Just a second, sir. I'm not able to open my presentation. Let me just. Actually, I'm not able to open my presentation. So
कोई बात नहीं, आप अपने गाइड से डिस्कस कर लीजिए.
Okay, sir.
ये दोनों सेम है तो you should use only one term.
Okay, sir. Noted.
Thank you.
Thank you.
Yeah, I have a question. I have one question, sir. Actually, you just mentioned about using the alternatives of this whole coal processing and either concrete processing, I should say. So you mentioned about the machine learning, how you are going to use this in particularly in this making the concrete uh, using the coal ash in a way that it can be helpful in making the concrete more effective. But you didn't mention any type of alternatives to the making of the coal process. You just mentioned about the coal ash that how it can be used in making the concrete much better.
Thank you for your question. Actually, I discussed about the various machine learning techniques which have been used in my particular in this research. And based upon those machine learning techniques, machine learning actually predict data. Actually, we cannot ignore the experimental work which we do in our lab. So from a machine learning, we get the result in the predicted way. So is the reason I have chosen this collage with
Yes,
machine
sir.
learning.
But all of these techniques are totally based on the coal ash only, or are they based on other things too? Like you are using the coal ash for the main purpose
These
of.
the okay, these techniques are not actually based upon this coal ash. We can use these techniques in any material. Otherwise, I also mentioned that there are some other material which can be used as a replacement for cement, aggregate, or some other materials.
Yes, sir.
So these techniques, whatever these soft computing techniques are, it can be used for all those. And based upon some previous literature, I got to know that the computing techniques which have been used in this study are the best from the past published research articles. This is the reason that I have used these three techniques.
Okay, sir. So they are for determining the properties of the these materials you
Yeah,
mentioned
they are for determining they are for actually the prediction, determining the predicted values.
on the properties.
Yes.
Okay, sir.
Thank you, Vipendra.
Thank you so much, sir.
Thank you.
Next, we have Mr. Deepak Thakur from HPU Shimla, who is presenting the topic Study of Various Computer Vision Algorithms for Registration in Augmented Reality.
Good afternoon, everybody. Am I audible?
Yes, sir, you are audible.
Wait a minute, let me present. Is my screen visible?
Yes, sir.
So, good afternoon, everybody. My research paper topic is Study of Various Computer Vision Algorithms for Registration in Augmented Reality. It's a survey paper. So, the presentation consists of abstract and the introduction part and role of registration in augmented reality, the conclusion and the future scope and the references added to it. So the abstract is basically about the definition of augmented reality and how registration helps with the placing of and aligning of virtual objects in the with the real space. So the registration algorithms helps in placing the virtually created objects in the most accurate position with the real world. So this paper basically shows the comparative analysis of various registration algorithms that comes under computer vision for augmented reality applications. So basically, what is augmented reality? It is a mix of real world with the virtually created objects. So it was invented in 1968 by Alvin Sutherland, who developed the first head-mounted display. But the term augmented reality it was given in 1990 by a researcher called Tim Cordell. So it is different from virtual reality because in augmented reality, the virtual elements are overlaid onto the real world, whereas in virtual reality, it consists entirely of the computer generated environment. So some of the real-time applications of augmented reality consists of mobile gaming apps like Pokemon Go, navigation purposes like it is used in maps and other apps for navigation. Social media apps like Snapchat, they use various algorithms for augmented reality purposes, and e-commerce websites like online IKEA to buy furniture, etc. So registration of image or an object that is to be overlaid can be done using various registration algorithms. So registration actually helps in accurately alignment of the virtual objects with the real world. So they are broadly classified into two types like indoor registration and outdoor. So indoor, that is between the four walls, and it is divided into two parts. One is SLAM and one is vision based. SLAM is a featureless based registration problem, and vision based is of two types, like using markers and markerless. Then outdoor registration consists of vision based, inertia based, and GPS based registration algorithms. So some of registration algorithms are like Shift, SURF, PTAM, NFT, etc. So the objective of this paper is to compare different vision-based feature using algorithms on the basis of their accuracy, its robustness, and real-time usage in the real-time environment. So the conclusion of this paper was that the different vision-based algorithms were compared, and it was on the basis of accuracy, its robustness, and real-time performance, and its occlusion handling. So the use cases of the algorithms were also discussed, and overall understanding of algorithms and their characteristics along with their thorough testing was done. So the conclusion was that the algorithm that can be selected is clearly based on the requirement of the user who needs to use it. In future, exploring different application of this registration algorithms in real world scenario and discussing about the scalability of the registration algorithms. More work can be done on the various factors such as system response, the stability of algorithm, and the factors that influence the use of augmented reality algorithms. And these are some of the references that paper. And thank you.
दीपक ठाकुर जी,
Yeah, yes, sir.
ये कंक्लूजन वाला स्लाइड देखना वाला आपने क्या लिखा है इसमें? कंक्लूजन एंड एंड
Conclusion में
हाँ, जिस पे कंक्लूजन है देखना वाला नहीं बोल
sir,
रहे थे कोई आपका।
typing error हो गया होगा sir.
एक चीज दूसरा, आप कंपैरिजन की बात करें, कंपैरिजन आपने दिखाया तो है नहीं कहीं में।
कंपैरिजन सर पेपर में मेंशन किया है ना, तो ये सिर्फ पीपीटी था एक ओवर पॉइंट देने के लिए उसका।
नहीं तो यहाँ पे भी तो थोड़ा दिखाना पड़ेगा ना आपको, अगर आप कंपैरिजन की बात कर रहे हैं।
दीपक जी, आप किसके स्टूडेंट हो, कौन सी क्लास के?
एमटेक।
एमटेक,
यस सर।
तो दीपक जी, मेरी ऑब्जर्वेशन है कि एमटेक स्टूडेंट्स हैं आप और एक इंटरनेशनल कॉन्फ्रेंस में पेपर प्रेजेंट कर रहे हैं, तो मेरे ख्याल से आपकी क्वालिटी ऑफ प्रेजेंटेशन फार बेटर होनी चाहिए थी। मेरे को यही लगा कि आप लोगों ने जस्ट पेपर की कुछ जो पोर्शन है वो पीडीएफ फॉर्म में आपने प्रेजेंटेशन के फॉर्म में रख दिए गए हैं, तो दिस वाज नॉट योर प्रॉपर पीपीटी। तो आप आगे से ध्यान रखेंगे, किसी भी अच्छी कॉन्फ्रेंस में अगर आप पेपर प्रेजेंट कर रहे हैं तो एटलीस्ट ऑडियंस को थोड़ा तो पता लगे कि आप लोग को ये प्रेजेंटेशन प्रेजेंट कर रहे हैं।
रियली सॉरी सर।
चलिए ठीक है, थैंक यू।
ओके, थैंक यू।
थैंक यू सर।
Next is Mr. Anush Gupta from Atal Bihari Vajpayee Government Institute of Engineering and Technology, Private Limited, presenting use of machine learning to detect COVID-19 through X-ray images.
कॉपी पेस्ट करते हैं सर, प्रेजेंटेशन तो की नहीं है, बोल ही दिया।
the best presentation. Best पता नहीं
Good afternoon, everyone. My name is Abhishek. I'll be presenting on the topic of use of machine learning to detect COVID-19 through a brief introduction. So everybody must be knowing about COVID-19, and we are using machine learning concepts on the images of COVID-19. The COVID-19 images dataset which we are using are of X-ray images. First of all, many of you might be asking later on that why I am using X-ray images rather than not MRI images or colored images. So I would like to just give a brief point over here that we are using black and white X-ray images of chest X-rays because if every one of you might be knowing about binary concepts, then X-ray images always it is easier to convert a black and white image into 0 and 1 form rather than an RGB image into 0 and 1 form because the resolutions of the images is a little bit of higher side. All right, so we will go into the presentation. So the first slide which I have made about coronavirus disease, you must all be knowing about COVID-19. Every one of us has been gone through a lot of a lot of us got sick because of COVID-19 also. So few types of which the COVID-19 disease is divided into is MERS and SARS. MERS stands for Middle East Respiratory Syndrome, and SARS is Severe Acute Respiratory Syndrome. So you might be knowing about many cases that which were of COVID-19 patients. They few had severe COVID-19 and few had a little bit of less COVID-19. So the severe cases were of acute pneumonia cases. All right. So the second case over here is of SARS. All right. So we were working on a platform to detect the COVID-19 through X-ray images. So use of machine learning, how we did that, I will directly go into the concepts like what objectives which we are dealing in this paper. Study and analysis of COVID diseases and their preventive measures. To investigate and propose a novel algorithm for detecting and predicting a COVID disease using X-ray images. Design a model for sending automated notifications of COVID disease and suggesting their preventive measures, and comparative analysis of novel algorithm with existing machine learning algorithm. So you must all be knowing about the machine learning algorithms. Over here we are using CNN, ANN techniques. All right, CNN stands for convolutional neural network and ANN stands for artificial neural network. All right, so methodology which we are dealing over here to finally do basic content to explore development of machine learning algorithms, distinguish chest X-rays of individuals with respiratory illness testing positive for COVID-19, and to promote discovery of patterns in such X-rays by machine learning interpretability algorithm. So flowchart, what we have made and what we are doing is given on the screen. So the collection of communication data set which we did was through, you must all be aware about Kaggle repository and UCI repositories. So UCI repositories are a little bit of refined data sets. They are all having a lot of data sets freely available on internet. Sorting and organizing the data. In the second phase, the data was sorted and organized. Why they were sorted and organized, I will like to come to this point. Because you must be knowing about the resolution of images. Every image is not of same resolution. So it is rather very difficult to work on different resolution of images rather than we work on same resolution of images. So we refined our images into same resolution type like 640 to 280. So we all tuned them up and made them into similar resolution. Training and testing using machine learning. So we did our training and testing of the algorithm over here. Simulation on the selected data set. Prediction of COVID using X-ray images which we were using. Send a normal report if it was not COVID positive, and set a detected COVID positive using X-ray images. Considering preventive action and storing the results for future. So The phases which we are divided over here are over the our framework into different phases. So first was data gathering, which I have already elaborated. Where did we fetch the data from? Second was noise removal. Now, what is this noise in our images? Noise you must be all really familiar with when you all make noise in classes. So every teacher says that you should not be making so much noise because it's really very hard to teach in that kind of noise. Alright. So in images, noise is something else. So in images, what is noise? It is distortion of the images. The images are distorted a little bit. So we tune them up, fine tune those images so that we can extract proper data from it. Now the third phase over here is data pre-processing. So data pre-processing is we will be refining our data and we will pre-process that data before implementing our technique over it like CNN and ENN. Then the final data extraction, we use a proper algorithm for data extraction. Then what techniques we are using? Use of learning algorithm like SVM, KNN, and the proposed CNN approach which we are proposing. Then training the data and the prediction of diseases that is their final step. All right, so the framework is given on the screen where we use the data set initially. We remove the noise, new and old data. We filter out the data. We filter out the data into training and testing images. Then the learning algorithm is implemented on it. That can be anyone, CNN, ENN, or whatever technique which you are using. Over here, we are using a collaborative technique. All right. Then we train the model, score a model, evaluate the model, and finally the disease prediction is done. So implementation and experiment was done on somewhere around 2,500 COVID X-ray images from the chest images. The basic age group of the patients was 58.8 plus 14.9. That means 14 years to 59 years our patients were, in which 131 males and 64 female patients were there. All right. So similarly, typical images were obtained from 1583 to 4292 pneumonia X-ray chest images. All images were measured in different dimensions and were therefore reduced into 614 to 480 dimension. All right. DT over here stands for the decision tree, contained 53 levels of teachable bounds and more than 3.4 million, the images data set. Now, why did we use decision tree? Decision tree, as the name suggests, may predict the decision. For example, we want to predict that whether the patient is having COVID or whether he is not having COVID. Alright, so decision tree is a helpful technique for us. So hybrid proposed approach over here, you can see in the second point, primary construction comprised of two convolutional layers that were with 64 and 16 channels. So you need to have a little bit of background and awareness about CNN, how convolutional network works. It is a filter of, I can say it is a refined technique of neural networks. We implement it on various data sets like images, audios, videos. All right, so there are few channels in it, so few phases in it. So with two completely associated thick layers with 128 and 8 neurons. Now, what are these neurons? Just like in our brain, you must be you are all aware about neural networks in our brains. So they are very thick and large number of arteries which are connected in which the signals travel. Alright, so in this examination, 640 into 480 X-ray pictures were resized to again 600 into 400, and afterward with 20 into 20 fragment sizes were applied over here. Accordingly, 30 into 20 X-ray pictures were created. Then the hybrid technique was implemented. Alright, see the most elevated mean exactness which we achieved was 98.34 accuracy, which we could get in from about sorry. Alright. So in about 2,500 images which we dealt with, 225 COVID-19 and 1583 normal patients were detected. So about 98.34% of accuracy which we meant. These are the comparative data over here, which was proposed which we proposed the hybrid solution, in which mean sensitivity was achieved as about 91%, mean specificity about 99%, mean accuracy, which was the most important one,
become 98%. And if we take an average of all the accuracy which we have achieved, we achieved around 95% of accuracy. The comparative work was done with DT. DT stands for decision tree. SVM stands for support vector machine, and KNN is knowledge neural network. All right. So these are different techniques which we implemented. The comparative technique, the comparative statistics analysis is given in front of you in form of bar graph, and ROC and AUC curves are performed over here. And proposed hybrid technique, you can see that the accuracy is almost comparing to other techniques, and it is a lot better than the existing techniques. Results which we dealt with mean precision values, we achieved 98%, around 98% persons were detected COVID positive, that is corona, and mean recall values 95% were detected COVID positive. The mean precision of which is compared with existing techniques like DT, SVM, and KNN is given in front of you, and the mean precision and mean recall is also given in front of you. The COVID positive patients which we detected were far better than the existing techniques. The the current COVID pandemic also it influenced every one of us. And though we decided to propose a solution like this so that every individual can get an access. Later on, we have also created a small website over there. We can fit our data set and check whether that the image is COVID positive or not. So this is all, and thank you. Any questions, if anyone would like to ask?
अनुज जी, आपका रिसर्च वर्क है या कोई?
सर प्रीवियस रिसर्च वर्क है। मैं इस पे काफी काम कर रहा हूँ। आगे मेरा काम लंग कैंसर पे है और ब्रेन कैंसर पे कर रहा हूँ। शुरू से जब मेरा रिसर्च वर्क चला तो इमेजेस पे काफी काम किया। तो ये छोटा सा एक प्रीवियस काम जो मैंने किया वो।
अच्छा, ठीक है। एक आपने
पेपर पहले भी पब्लिश हो चुके हैं।
अच्छा, वेरी नाइस। एक छोटा सा क्वेश्चन था कि आपने अपनी प्रेजेंटेशन में बोला कि जो बेसिक एज है वो आपने 58.8 प्लस माइनस 14.9 कुछ ऐसा लिया। इसका कोई बेस मतलब ऐसा क्यों?
एक्चुअली मेन जो डेटा सेट था मेरे पास जो अवेलेबल था वो समवेयर अराउंड 15 एज ग्रुप से लेके 60 एज ग्रुप तक था।
अच्छा।
तो उसको हाईलाइट करने के लिए वो मेंशन किया वहाँ पे कि मेरा एज ग्रुप जो था डेटा सेट में इतना था। बेसिकली क्या था कि जो छोटे एज ग्रुप के लोग थे यानी कि 14 to 15 ईयर से कम जो एज ग्रुप के थे बच्चे जो थे उनके टेस्ट रिजल्ट्स अवेलेबल नहीं थे हमारे पास, क्योंकि वो अगर इनफैक्ट होते भी थे तो पेरेंट्स उनको हॉस्पिटल वगैरह या टेस्ट वगैरह उनके प्रॉपर्ली नहीं होते थे, तो डेटा सेट्स उनके काफी कम थे। अब हमें एक्यूरेट जो प्रेडिक्शन करनी होती है तो सर एटलीस्ट 3000 इमेजेस हमें चाहिए, एटलीस्ट चाहिए, तो प्रॉपर्ली एक्यूरेसी के लिए, तो इसलिए वो नहीं मिल पाई तो मैंने उनको हाईलाइट भी नहीं किया सर।
मतलब डेटा सेट अवेलेबल नहीं था इसलिए ये वाली रेंज ली आपने?
प्रॉपर डेटा सेट नहीं था, ऐसे 100 120 इमेजेस अवेलेबल थी, तो उन पे एक प्रेडिक्शन लगाना या एक्यूरेसी रिजल्ट जनरेट करना वो मुझे नहीं लगता कि एक्यूरेट कुछ प्रेडिक्ट कर देगा।
तो रिकैलिंग का क्या मतलब होता है इसमें? व्हाट इज रिकॉलिंग? रिकैलिंग या जो आप बोल रहे हैं?
रिकॉलिंग सर, रिकॉल बेसिकली मींस लाइक वी आर डीलिंग विद प्रिसिजन वैल्यूज ओवर हियर। रिकॉल एक मीन स्पेसिफिसिटी हम चेक कर रहे हैं, मीन एवरेज जो चेक कर रहे हैं, जहाँ पे हम रिकॉल करते हैं F1 स्कोर्स जनरेट करते हैं। बेसिकली क्या है, पाइथन पे हम लोग जो कोड करते हैं उनके हम रिजल्ट्स जनरेट करते हैं ग्राफिकल फॉर्म्स में। तो F1 स्कोर है, कंपैरेटिव रिजल्ट्स हैं, फिर मीन स्पेसिफिसिटी है, मीन एवरेज है, और भी कई चीजें हैं सर, और भी कई पैरामीटर्स हैं जिन पे हम इनको टेस्ट करते हैं।
Thank you so much, sir. Next, we have Ms. Jaspreet Kaur from PTU, who is presenting on the topic a comparative analysis of algorithm and exploring the effectiveness of machine learning approaches in predicting mental health. Jaspreet Kaur, ma'am. I kindly repeat, this is the call for Ms. Jaspreet Kaur from PTU, who is delivering a session on a comparative analysis of algorithms and exploring the effectiveness of machine learning approaches in predicting the mental health. Kindly answer if you are here, ma'am, or we'll move on. Okay, we'll be moving on.
Once again, ask and then you.
Final call for Ms. Jaspreet Kaur from PTU, who is delivering a lecture on a comparative analysis of algorithms and exploring the effectiveness of machine learning that approaches in predicting the mental health. Final call.
Leave it, move on. Later on she will come, then she will present. If
Our next presenter is Mr. Lovely from Rayat Bahara University, presenting on the topic a hybrid machine learning approaches for transparent lung cancer prediction with emphasis on interpretability, scalability, and generalizability. Mr. Lovely.
Hello.
Hello. Hello. Are you audible to you? Hello.
Yes, ma'am. You're audible to us.
Hello.
she sends
Ma'am, you are audible to us.
Okay. Hello. Good afternoon, all of you.
Mr. Lovely.
Yes, sir. Hello.
Say.
Hello. Are you audible to you, sir?
Yes, you are audible.
Okay, sir. Good afternoon to all, sir.
Very good afternoon, ma'am.
Kindly proceed with your presentation.
Okay, sir. Okay. Hello.
Yes, you are audible.
Ma'am, just to remind,
Actually, sir, नेटवर्क की वजह से ना शेयर नहीं हो पा रही है.
कोई नहीं देख रहा है
आप एक बार retry कीजिए.
तब तक करो.
Hello.
You are audible.
मैम आप audible है, आप एक बार retry कीजिए please screen share करने के.
मोबाइल सेटिंग होगी तो शेयर होता है
इस पे सेटिंग होगी ना शेयरिंग नहीं होगी.
हाँ तो कोई नहीं लैपटॉप
मैम आप अपनी presentation खोलिए please.
सर एक्चुअली शो नहीं हो रही है ना वो वहां से.
Miss Lovely, you can use laptop instead of your mobile, I think. चल पड़ेगी सर.
बोलो मिनिमाइज करो इसको.
मैम स्क्रीन मिनिमाइज करके आप अपनी presentation ओपन कीजिए, हमें विजिबल हो जाएगी.
ये शेयर है.
स्क्रीन शेयर्ड है. हाँ जी, हमें दिख रही है. आप एक बारी प्रेजेंटेशन खोलिए. मैम हमें दिख रही है आपकी स्क्रीन.
ओके. सर आपको शो हो रही है?
यस मैम, हमें शो हो रही है. आप बस प्रेजेंटेशन.
Sir, I am Lovely from MTech student from Rayat Bahara University.
मैम आपकी प्रेजेंटेशन अभी वॉच नहीं हो रही है. आप सिर्फ अपनी प्रेजेंटेशन ओपन करके रखिए. ये वाली स्क्रीन मत ओपन कीजिए.
Okay.
हमें नहीं दिखेगी तो हम आपको बता देंगे, अभी हमें विजिबल हो रही है।
Sir, my topic hybrid machine learning approach for the traversing lung cancer prediction with the emphasis of
Basically, your
intermediate
PPT is
scalability.
not visible to us.
मैम आप अपनी प्रेजेंटेशन खोलिए प्लीज, पीपीटी। मैम आपने जो प्रेजेंटेशन बनाई है आप बस उसे शेयर कीजिए, हमें आपकी स्क्रीन बिल्कुल विजिबल है।
Dotted पे
आप मिनिमाइज कीजिए, आप अपनी स्क्रीन मिनिमाइज कीजिए।
sharing your screen with everyone.
इस स्क्रीन को मिनिमाइज करें आप, सेंटर बटन या लेफ्ट बटन दबाएं। आप पीपीटी पे क्लिक करें, मेल
हम डायरेक्टली आप पीपीटी पे क्लिक करें। हाँ,
आप पीपीटी पे
आप इसको पीपीटी पे क्लिक करें।
खोलिए पीपीटी।
मैम
हाँ पीपीटी खोलिए। ठीक है।
Okay, देख रही है सर आपको?
नहीं देख रही, पीपीटी खोलिए आप।
सर मैंने पीपीटी ओपन की हुई है।
आप पीपीटी को स्क्रीन पे लाइए। नहीं
वो शेयर्ड है उसकी उनकी स्क्रीन। आपने पीपीटी खोली है मैम, अभी नहीं दिख रही आपकी, तो मेन स्क्रीन होम स्क्रीन दिख रही है आपके फोन की।
सर यहाँ पे स्टॉप शेयरिंग आ रहा है।
हाँ नहीं आपकी शेयर्ड है।
हम आपकी स्क्रीन शेयर है, आप अपनी प्रेजेंटेशन को ओपन कीजिए, हमें दिखाइए।
लैपटॉप तो टाइम वेस्ट होता है।
10 मिनट
आप बैक चाहिए,
ओके।
मिनिमाइज कीजिए स्क्रीन को।
अगले फाइल फोल्डर पे जाकर वहाँ पीपीटी यूज करते हैं।
हाँ फाइल, आपके फाइल फोल्डर में जाके पीपीटी ओपन कर लीजिए आप ना, फाइल फोल्डर में जाके जहाँ भी पीपीटी आपकी स्टोर कर रखी है आपने।
ओके सर।
हाँ 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 एग्जैक्टली। इस मोबाइल स्क्रीन पे तो कुछ विजिबल ही नहीं होगा। विजिबल ही नहीं होगा सर कुछ।
मिस लवली आपके पास लैपटॉप होगा?
सर लैपटॉप है, मैं लैपटॉप से ही कर रही हूँ ना सर।
तो करेक्ट मैम, अगर आपके पास ये आपकी मोबाइल स्क्रीन है, अगर आपके पास लैपटॉप है तो आप लैपटॉप से कनेक्ट कर लीजिए प्लीज, और उसके बाद स्क्रीन शेयर कीजिएगा, हम आपकी उस टाइम प्रेजेंटेशन करवा देंगे।
तब तक नेक्स्ट
नेक्स्ट कर लो, नेक्स्ट
कर लो। नेक्स्ट को कॉल करो ना अब।
इनसे बोलो स्टॉप शेयरिंग करें ना, तभी तो नेक्स्ट शेयर करेंगे।
तो भी ऑनलाइन है।
Miss Lovely, you can stop sharing your screen now. We are calling the next participant. Meanwhile, you sort it out, whatever problem you are pursuing.
ओके सर। ओके सर, थैंक यू।
थैंक यू मैम। सर विल बी फॉर अ होल्ड फॉर अ मिनट, एक कंफर्मेशन लेनी है हमारे नेक्स्ट पार्टिसिपेंट।
अच्छा वेरी जी। उनको आ नहीं रहा है वो उनको बता दो ना, 3 डॉट बन रहे हैं वहां से स्टॉप शेयर।
आप स्टॉप शेयर
3 डॉट्स बन रहे हैं ना मैम वर्टिकल में। हाँ
नेक्स्ट ये कौन है? डॉक्टर अतुल गुप्ता। এটা করো কল अतुल गुप्ता कौन ओपी 17 डॉक्टर अतुल गुप्ता एंड डॉक्टर संजय कुमार है नहीं इनका
मिस लवली आप अपनी स्क्रीन शेयर करना बंद कर सकते हैं प्लीज
बस हो गया फिर खत्म
हेलो
यस मैम
सर एक्चुअली प्रॉब्लम आ रही है, अगर आपको मेल कर दूं मैं सीधा सर।
हाँ मेल
करा लो तुम शेयर कर दो
शेयर तुम कर देना
ओके मैम आप हमें मेल कर दीजिए प्लीज
ओके सर, जिस पे मैंने मेल की थी पहले उस पे ही कर दूं ना?
जस्ट अ सेकंड मैम होल्ड कीजिएगा प्लीज मिस लवली
यूनिवर्सिटी
आपको आवाज आ रही है
अतुल गुप्ता हाँ
मैम आप हमें मेल कर सकते हैं GHEC workshop@gmail.com small g small h small e small c WORASHOP@gmail.com
ओके सर, ओके सर, थैंक यू।
ये हो गया जो फोन किया था ये हो ये हो गया ना छोटा है इसमें और ये लवली का भी सेटिंग ये सेमिनार ऊपर चलेगा सेमिनार ऊपर चलेगा ये दो है NH अभी अभी डॉक्टर
हेलो 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 हेलो
हेलो
हेलो
हेलो
हेलो गुड आफ्टरनून
हेलो, गुड आफ्टरनून।
दिस इज डॉक्टर सुरेश मैम
हेलो
हेलो मैम डॉक्टर सुरेश फ्रॉम गवर्नमेंट कॉलेज ऊना मैम हेलो
आवाज आ रही है
हेलो
बोलो सर
सर हेलो सर आवाज आ रही है मेरी
जी सर आ रही है आपने गलत रूम में ज्वाइन किया है सर आपका जो रूम है वो सेमिनार हॉल से कनेक्ट होगा हम कॉन्फ्रेंस हॉल से कर रहे हैं मीटिंग
ओके सर
कोड अलग होगा ना
आपको दूसरा कोड
लिंक अलग होगा आप गलत लिंक ज्वाइन किया बोलते
आपने गलत लिंक ज्वाइन किया
ओके सर सॉरी सॉरी सर
हेलो 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 हेलो
हेलो मैम एम आई ऑडिबल
ओके सर, मैंने अभी ये सेंड की है आपको मेल ना?
आप अपनी ईमेल आईडी कंफर्म करवाएंगे प्लीज
Sir, lovely. Hello.
फील नहीं हुई है आपने आपने जो मेल एड्रेस है वो आपने एक बार आप उसकी स्पेलिंग चेक कर लीजिएगा स्मॉल
Hello. 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 Hello.
बस लवली
इसमें मिस हो गया ये?
हम ऑडिबल है आपको
ओके
इसके
सर
बाद
एक्चुअली मैंने मेल सेंड किया अभी आपको ना।
मैम अभी तक रिसीव नहीं हुई है हमें
कल के लिए ना पहले मान लो सबसे जो भी पीपीटी है वो पहले भेजना पीपीटी
आप एक बार
एक बार ना बड़ा
सेंड ऑप्शन है जीमेल में उसमें जाकर चेक कर लीजिए कि जो मेल है वो चलेगी है या नहीं
नहीं सर वो चलेगी आपको मेल ना।
प्रीवियस एक लेसन
नहीं
है
हुई है
कि इनकी पीपीटी मंगा लेने पहले नहीं व्हाट्सएप पहले दे दो
आप मेक श्योर कीजिए मैम कि आप लैपटॉप से यहाँ पे कनेक्ट कर लीजिए और उसके बाद आप अपनी स्क्रीन शेयर करके प्रेजेंटेशन प्ले कर दीजिए प्लीज
ओके सर ओनली आप 5 मिनट दीजिए सर मैं अभी कर देती
श्योर मैम
हूँ। ओके सर थैंक यू।
मैम लवली मैम फॉर द टाइम बीइंग आप अपनी प्रेजेंटेशन जो है वो वर्कशॉप वालों के व्हाट्सएप ग्रुप पे उस पे शेयर कर दीजिए प्लीज
ओके सर ओके अभी कर देती हूँ।
जी अच्छा चालू हाँ चार से ठीक है जी सर, 4 से 4 ठीक अब दोनों पता तो तू प्रेजेंटेशन में दे रहा है, पता कैसे चलेगा इवैल्यूएशन है क्या है? सारे के सारे डालते हैं ना प्रोसीडिंग में। सर बताएंगे, वैसे तो उन्हीं को डाल
I would like to inform you all that
दोनों से भेजो,
support the email.
रजिस्टर्ड मेल से भेजो।
Hello.
Yes, we are audible to you.
Yes, sir.
Okay, let me introduce you with our online and offline audience. So, Mr. Asyam, who is currently a scientist at DRDO, Defense Research and Development Organization, he received his PhD degree, bachelor's degree in 2009 from National Institute of Technology, Patna, with a robust skill set that includes MATLAB and Simulink, control system design, C++, and more. Kumar Rashyam contributes valuable insights to the industry and obtained Lab Scientist of the Year award in 2021. He is also pursuing his PhD from Indian Institute of Technology, Hyderabad. His research interest includes DC-DC converters, solar power system, and solar panels. So I request Mr. Rashyam to share his in-depth knowledge and key points on the topic satellite power system, and also request the audience to be attentive while listening the presentation and ask questions too. So, Mr. Rashyam, it's over to you. You can continue.
Can you see my slides?
Yes, sir. Your slides are visible.
Okay. Thanks for giving a nice introduction about me. First, I want to thank Dr. Himanshu Monga sir, Director cum Principal, Government Hydro Engineering College, Bandla, Bilaspur. I also want to thank Dr. Deepak Bansal sir, Director cum Principal, RGG EC, Kangra, present there. I also want to thank Dr. Abhishek Diman sir, Convener RTEST 2024, and all other distinguished dignitaries available in this conference. It's really an honor to be here today, and I'm delighted to give a presentation on the topic satellite power system. So basically, it's about the design and how your management you are doing. So coming to the satellite overview first, shall I start now? Fine.
Yes, you are audible and your presentation is also visible.
So first I want to tell all the complete audience about the satellite overview. So satellite consists of various subsystems. So what you can see, this is a solar panel, battery and battery management system, and productions, power control card, and sensor and relay. These are the part of the satellite power systems. Apart from that, there are different systems also, like telecommand receiver, telemetry transmitter, BMU, bus management unit, GPS receiver, rejection wheel, torquers, thruster, heaters, mechanisms, payload, gyros, star sensor, and different systems like that. So basically, satellite power systems function is to give the power to the supply the power to the different satellite systems, and during different modes basically. So we'll discuss in detail about the different modes also. So based on the different weight of the satellite, it is categorized into different categories. So from 10 gram to 100 gram is femto, 100 gram to 1 kg is the pico, and 1 kg to 10 kg is the nano, 10 kg to 100 kg is the micro, and similar like large, you can see more than 2000 kg is the large satellites. So these are the educational satellites which is already flying in the low Earth orbit. So these are ANU set by the Anna University College, SRM set by the SRM University, Jugnu by I think IIT Chennai, Satyabhama set by the name also you can say Satyabhama University. PISAT is by the TES University, Pratham by the IIT Mumbai. So there are many satellites which are not only developed by the ISRO or DRDO, but also by the educational institute like many institute like this. So this is the one of the picture of Pratham, which is developed by the IIT Mumbai students itself, and this is the PISAT by the TES University. So it is both are supported, reviewed by the ISRO scientist, and finally it is flown into the orbit. So apart from that, apart from the based on weight, there are different classification. Like it's also about the orbit classification. Like if it is between 200 to 2000 kilometers, so it is a low Earth orbit. So if it is between 2000 to 20,000 kilometers, it is mid Earth orbit, and if it is at 35786 kilometer altitude, so it is geosynchronous orbit. Apart from that, there is also highly elliptical orbit. So you can see what is the use of that. If you can see, if you want to monitor a particular area, like if you want to monitor only a polar thing, like in the Russia region, for a maximum number of or maximum time, like in the sea, you can see one of the figure here. HEO is for nearly 80% of the time. So if you want to monitor a particular area for a maximum period of time, so then HEO orbit is useful. That is Molniya orbit, but it is used in the Russia mostly. Apart from that, first I want to give the satellite overview that it's basically of the payload, because objective of the satellite is decided by the type of payload. If there's a camera, like you can see, so camera can take the picture. So in our scenario, like if you want to know, okay, like in the border area and all, what is going on, so that camera can be useful to take the pictures if any roads development is there nearby or something like that. So apart from that, radar can be also a payload. We can able to detect the different RF instruments like electronic warfare available across the borders. And astronomical instruments also for the outer space, useful for to know about the different bodies into the space. So payload is one object and other is a mainframe. So what is mainframe? Basically, mainframe consists of the other systems to operate the satellite itself, like structure, thermal, mechanism, attitude, propulsion. So power is one of them. So system has to meet the mission goals by supporting demands of these loads under various load conditions. So first is the launch phase. So during launch phase, we'll think what will happen. So when a satellite will be launched from the ground to up to the orbit, by that time our design schedule of the power systems will be like that. It should be complete load will be on battery, because that time solar panel was not deployed. So launch phase basically we have to design based on the battery. Battery if we design like that, it should able to meet the launch phase condition. Apart from that, in orbit condition, we have to see how much is the eclipse time, how much is the sunlit time. Based on that, we have to design the solar panel and the battery both. So basically, eclipse and imaging both are will be with the power by the battery, because that time like in eclipse, sun is not available, so solar panel can't generate any power. And imaging also, we have to look towards the, like if you want to take the image of the complete like Earth, you want to take the picture. So if you see the configuration of the satellite, so at that time your solar panel will not look into the sun; it will look toward the Earth. So that time solar panel can't generate much power. It will generate some power, but not it. So for a design purpose, imaging we can consider it as a zero, and so complete load will be on the battery itself. So coming to the next, like satellite configuration, what I'm talking about, you can see that there's two deployable solar panel is here mentioned. So this is the exploded view of the complete satellite system. So all the systems we have to place based on the functionality, and also based on the functionality and also based on the payload also. You have to configuration has to be done. Apart from that, thermal also to be considered for the placement of the subsystems also. So coming to the next, so we have already discussed all the systems, so we'll go to next. So what are the issues basically in the space for the satellite power system? So people will say that power system is nothing, that we just give the power to the satellite system. But if you see, most of the failure in satellite is because of the power system. So in 1996, you can see I have listed down the few of the failures. So solar panel in Canada, even satellite was disconnected. Similarly, there was a power bus anomaly in INSAT 2D, that is the ISRO satellite. Then short circuit in the primary bus. Basically, in this, what is difference from the ground to the earth to the space? First, you have to think like that. So basically, radiation is the things which is extra from the ground to the space. So what are the components we have to select? It should be prone to radiation. So most of the MOSFET are prone to radiation failure. So So you can see that inside 4B partial power failure from one of the solar panels. Similarly, Chandrayaan also DC-DC converter power is failed in the Chandrayaan 2 and 8. And even satellite loses contact because of power failure in GSAT-6A also. So does this make the satellite power system critical system in the space domain? So we have to be first able to design a satellite power system in such a way it should be highly reliable. So I have listed on the feature of the satellite power system as it should be highly reliable first, and it should sustain the harsh radiation environment. What I was talking about. So apart from that, it should be efficient, clean power supply full power during the mission, resiliency to sustain, compact, redundant, low size, high power density, and low cost. So these are the features required for developing a satellite power system. So what satellite power system will do? I already told, but I will just read once more that it will generate and supply the electrical power to a different satellite system, condition, convert, control, and distribute the power to loads. It will meet the average, that is continuous load of the housekeeping, and also the peak load. Basically, peak load because when we are using the payload, imaging and all. It protects the spacecraft during a satellite power system failure, provide energy storage for eclipse and peak demands, and provide specialized power specific to function like in the pyro or deployment mechanism. So this is a block diagram of satellite power system. So what it consists of? It is a solar panel, which will generate the power during sunlight. This is the battery. So mostly we are using the space qualified lithium-ion battery to store the energy and support spacecraft load during eclipse and peak loads. And also during the launching phase that I already discussed previous slide. Apart from that, power system electronics will have the power control and power distribution. Basically, what will do, it will manage the power input from the solar panel, and it will also control the charge discharge of the battery, because battery should not get overcharged. So that should be maintained by the some logic. So that power control will control the overcharging of the battery. It will protect the battery, distribute the power to the different satellite subsystems. It will also monitor operation, and it will have the health status of the complete PSC subsystems, as well as it will communicate. It will also have the health status of complete loads also, like all the subsystems. So and it will transmit the complete telemetry data to the telemetry and BMU. So we have to design a solar power system in such a way so it can able to meet from the beginning of life to the end of life. So what does it mean basically? So in the beginning of life, our degradation will be very less. So at the end of life, my solar panel will degrade, my battery will degrade. So at the end of the life also, it can able to meet the power requirement of the complete satellite systems. So our design should be like that. So coming to the power system function, so this is the flow chart basically how it works. So it is the power source. So it will it can be controlled, some source controls will be there. Then power management and distribution, power processors and loads. So these are the energy storage, that is nothing but a battery, and its control. So what are the different type of power source available around? If you see in the market, it can be solar photovoltaic. It is nothing but a solar array, radioisotopic thermoelectric generators, nuclear reactor, solar dynamic fuel cell, and primary batteries. So how you can control these power sources? It can be controlled through the shunt regulator, series regulator, and sorting the switching array. Similarly, what are the power conditionings available like DC-DC converters, DC-DC, DC and AC, and storage? I already told the batteries and the flywheel. So coming to next, based on the load and also the how much mission life you want. Let's suppose your mission life is 5 years or 3 years. So we can't use primary batteries at all. We have to use the photovoltaic only, like solar panel only. But if your load requirement is very high, like in thousands or hundreds of kilowatts, so you have to go with the nuclear. So it is like a trade-off. It's like a trade-off between what to be used and which power source to be used and when, based on the mission requirement and the load requirement. So coming to the energy storage, so I already explained that it will supply during the eclipse and the peak loads. So these are the different batteries: nickel cadmium, nickel metal hydrogen, lithium ion, lithium polymer, and nickel chloride. So this is the graph basically showing that specific energy density with the volumetric energy density. So we have basically we have to use the battery which is having the lighter weight, and also it can have the high energy capacity. So in this, if you can see, as per the heritage, space heritage, lithium ion battery is the best suitable till today. In future, we may be having the better batteries also. So power system electronics, so basically it will manage the source and battery, bus control, power conditioning, and the production and monitoring provision. So this is one of the hardware of power system electronics. You can see that it's just very small and compact. So coming to the now design of space qualified solar panel. I just told the introductory things first. Now coming in detail. So what is solar cell which will convert the light energy into the electrical energy? So each solar cell is having the bypass diode, that is inbuilt it is having. Apart from that, it is also having the interconnects. So it will connect the other cells. So based on the number of cell required in series and parallel, these interconnects are connected between the cells. And bypass diodes is basically to protect the string. Basically, if any solar cell is get damaged, still it can able to supply the current because bypass diode is there. Even if there is a shadow, so shadow also it can be taken care with the help of the bypass diode. So you can see that what are the different type of solar cell available. So single crystalline, gallium arsenide, thin film, two junction, and triple junction. Now people will say that four junction solar cell also came into the market. Its efficiency is about 32 to 33%, but it is not qualified as per space heritage. So I'm not mentioned here. So what is available in the market is up to 30% efficiency only, triple multi-junction cell solar cell. So these are the complete details what research is going on solar cell. So students nowadays can do research on people are doing also on solar cells. There are different types of solar cells available, like multi-junction, single junction, crystalline, thin film, and emerging maybe like dye, organic cells, inorganic cells, and quantum dot also. So we can see based on that what is the efficiency of the different solar cell. But I can say that apart from multi-junction, we are not using in the space domain because other are not matured enough. Like thin film and emerging PV cell, what we are seeing, it is not get matured. So maybe in future we are going to use this. So as of now, we are using only triple junction solar cells as the space solar panel. So they are the heritage of solar cell. You can see that only few countries are having solar cells, space qualified solar cell basically. So Spectrolab USA, Spectrolab Amcor, Azure Space, Clyde, and Pumpkin. So they are the developers, and so only few solar cells are available. So maybe in future, a good institute like you maybe can develop, will research on the solar cell and can develop the indigenous solar cell and can be useful for the space mission in the future. Coming to the next section of space qualified solar cell. So I want to explain that why triple junction is giving the more efficiency basically. So triple junction means like gallium and indium phosphate, they will absorb the different bands of sunlight and it will have the more efficiency. Like gallium and indium phosphate will have the 1.86 electron volt. Similarly, gallium arsenide is 1.42 and germanium is 0.66 electron volt. So each layer will absorb the different band of sunlight and it will increase the efficiency of a single junction to triple junction. So what we are using is this cell in space qualified. It is gallium arsenide, gallium indium phosphate, and germanium solar cell, which is having the 100 micrometer cover glass thickness from this from the Azure space. Similarly, we have seen that it is also Spectrolab is also having, and Solero also having the space qualified solar cell. So these are the specification of the solar cell. This is the beginning of life, and these are the data after radiation. So you can see after radiation, our voltage and current will change. That's why I'm telling that after a mission life of let's suppose 4 years or 3 years, end of life, we will design based on end of life. We can't design at the end of life. So coming to the different parameters like orbital parameters, this also have to be considered for designing the solar panel. Like you can see that like size and period. So it will decide the period will give the total time period of the satellite. So time period will give how much is the eclipse total time basically, and inclination will give the total eclipse time. So for solar panel, we will come to know what is the what will be the eclipse time and what will be the sunlit time. This will give, because this is required for designing the solar panel. So apart from that, the difference, many of you might have read, it is sun synchronous orbit. So whatever satellite you have seen, I have given the example. All satellites which are in the LEO, most of them are the sun synchronous orbit. What does it mean? It means that if first you know that it is synchronous, so it is synchronous to the sun. Apart from that, it will cross the particular latitude of the like it will pass the equator at the same time. Like one example, that if you are launching a satellite and it will pass the Earth or any ground station at the particular time, plus minus 15 minutes is the error, but nearly at the same time it will pass. So it will be very useful for data dumping, like whatever the image we have taken picture along the globe, we can dump at particular time. So it is good for the time management, or the sun synchronous orbit is useful for that also. So for designing, there are things we have considered for designing the solar panel. So satellite stabilization also. Like if satellite is spin stabilized, so it should be, the panel should be body mounting. But if it is a 3-axis stabilization, it can be rigid solar panel or with SADA. So due to the different positions of the sun in different months, so we can see that suns will be nearest during the second day, and it will be farthest during the July times. So based on that, also we have to see that how much energy we are getting generated through the solar panel. So this is one of the video. So I want to explain this, that yellow part is the sunlit time. So whenever any satellite is entering into the eclipse, it will first maneuver toward the earth pointing mode, so that star sense, to protect from the star sensor. So similarly, if this is the eclipse period. Blue is the nothing but the eclipse period. Again, coming out of the eclipse, it will move toward the sun pointing mode, and it will track, the solar panel will track toward the sun. So it will generate the power. So whenever the area of interest will come, they will do the imaging, integrate the imaging, and it transmit the data to the ground station. So Hyderabad, I have pointed out here. This is one of the small video, just to show that how satellite works. So this is the typical orbit of satellite. So maneuvering was mostly in typical orbit, maneuvering 3 minutes, mostly in good. And pointing will be about 45 minutes. Again, maneuvering coming for doing the imaging, in the imaging part, then again maneuvering toward the sun pointing mode. So nearly 12 minutes will be the maneuvering, nearly 10 minutes will be data transmitting, and so I am to tell that nearly 25 minutes if you take as a total time period of the orbit of a satellite. So nearly 35 minutes will be the eclipse and 60 minutes will be the sunlit. So in that yellow part we can see this is the sunlit time, and the blue part nothing is the eclipse time. In that, what are the different modes we are performing by the satellite? These I have already mentioned here. So if you see that eclipse duration as per mission, like 930 orbit if it is there. So eclipse is not constant; it is changing with the days. And it is 6 a.m. orbit. In this also eclipse, how it changes, I have depicted here. So these are all useful for designing the solar panel. So even the magnetic moment. So like to balance the magnetic moment, so solar cells should be placed like that. Two will be like this, and other will be like this. So connection with positive terminal, negative terminal should be opposite to that. So that magnetic moment should be balanced for the complete solar panel layout. So coming to the solar cell characteristics, so we can see that this is the IV curve, the solar cell. So our design should be like that. The solar cell will be giving the maximum at maximum power point. So this is the PMT. So our design should be whatever design we can do, like direct energy transfer or MPPT. We have to design on near to this only. So we can see that how the intensity of the sun also varies. If intensity varies, VOC of the solar cell also varies. So this will finally affect the power generation. So this also have to be considered how so that solar panels should look directly toward the sun. There should not be any angle, because any cos theta angle will reduce. Apart from that, temperature also it is dependent. So if you can see, if temperature is more, our open circuit, our voltage will be reduced drastically. So with the temperature, how solar cell characteristics is changing, this also have shown here. Apart from that, there is an effect of radiation also. You can see that from the beginning of life to the end of life, what is the basically effect on solar cell? Nearly 3 to 5% loss will be also found. So these all. So this is the actual design basically. We have just taken out a simulation data to show you how with the 25 degrees Celsius to 80 degrees Celsius, how my voltage will change. Similarly, if intensity changes from 1302 to 1411, how much is the change in the current and the voltage of the solar cell? Similarly, for the end of life and the beginning of life. So this is the actual data. So this is the solar panel structure and cross sections. So you can see that it is having the thermocontrol surface, phase sheet, adhesive, then honeycomb core, adhesive again, phase sheet, adhesive, insulator, and upon that we are putting adhesive and pasting the solar cells. So solar cell consists of the interconnect and also the cover glass. So what are the design consideration of solar array? Solar array is basically based on the voltage and the current requirement. We have to arrange the solar cell in series and parallel configuration. So cell in series provide the voltage requirement, and cell in parallel provide the required current. So for each of control, the parallel cells are again divided into the number of strings. Like we have to make a master string for that. Apart from that, you have to also consider the radiation, brightness drop and diode drop, loss factor. Sudden can also cause cell hotspots, and so we have to see the failure of that also. Based on the load power and battery charging requirement, also it is considered for this. So deteriorating and generation with the seasonal variation, end of life generation also it is considered. Apart from that, we have to consider the packing efficiency, type of cell, and one string failure also. So these are the design questions. I'm just skipping this. So these are the picture of solar panel and the front and back. You can see that front we can see the solar cell, but back side there is a complete electrical wiring diagram. So this is also challenging because you have to select a diode and all, and which can sustain minus 100 to plus 100 degrees Celsius in the space. So if you see any data sheet, your diode and all can't meet minus 100 because it's having constraints up to minus 5. Mill standard also minus 55 to 125 degrees Celsius only can be met. So you have to qualify everything to meet the space requirement. So this is the body mounted solar panel. What I told, spin stabilization if it is there, and if it is there, the 3-axis stabilization, so it can be panel mounted. So what are the different type of effects on solar panel? So magnetic moment, I already told that if we can have alternate panel like from one in this direction, positive direction, other in negative direction, so magnetic moment will be balanced. So this is required to have the magnetic moment should be 0 of the solar panel. So we have to select a component, all the components like diodes, wiring, so that outgassing should be not be there anything in the background. Even it should have the protection from the debris and meteoroids. Basically, we are not using any protection as of now, but we'll analyze before launching that what is the probability of debris in the space. Effect of atomic oxygen. So we know that we are connecting the two solar cells through the interconnect. So interconnect is basically having silver. So basically it can get damaged through atomic oxygen available in the space. So we are for that also we have some protections. So it will be get rusted. Apart from that, ESD also we have to take care, Earth magnetic field and radiation also. So coming to the space qualified battery. So space qualified battery support during launch and ascent phase. It provides during the eclipse and also during the peak demands. So basically for designing the space qualified lithium-ion batteries, you have to see the number of charge discharge cycle. This is the major point for designing the battery, because if you see what are the battery you are using the mobile, their cycle is if you start with the 100% DOD depth of discharge, it cycle will be maximum of 1000 only, not more than that. So if you see our complete satellite itself for the mission life of 5 years, nearly 35 to 40,000 cycle is required, charge discharge cycle. So 30-40,000 cycle, how can we meet? So there is a based on the depth of discharge and the charge discharge cycle, there is a graph is there. So based on that, you have to take a decision what we want basically. How much charge discharge cycle we want and how much depth of discharge we can take care. If you can go, let's suppose 50%, what is the charge discharge cycle it can support? So based on that, we have to design the battery. Similarly, the space qualified lithium battery major problem is the stringent temperature, the operating in a stringent temperature. It can operate between 10 degree to 30 degree only. So the environment to maintain that is again a challenging in the space, because we have to give an environment between, we have to maintain temperature of 10 to 30 only so that our lithium battery can work. So the battery capacity is the other features. It should have the high energy density, because you know that in the space the major problem is the volume, space, the basic dimension, and also weight. So it's how much less will be there, it is better for in the space. So lithium ion is good in that aspect, but it is also having the best self discharge, because if you see the our battery which is available in the lead acid battery available in the household, they self discharge about 30%, I think. If you see the lithium ion battery, it can discharge 2 to 3% only. So it's good in that sense also, and it's ease of maintenance. The different type of major type of batteries are the lead acid batteries, which is only for the terrestrial use, for both terrestrial and space use. Nickel hydrogen already used in the space, but people are now shifting to lithium ion battery. So why lithium ion is used in the space? Because you can see, so it is having the 120 watt hour per kg storage, and also the life is about more than 15 years. This is the parameter of the lithium ion cell. So, and you can see from here that with the depth of discharge and how voltage is changing. So to see the state of charge of the battery. So based on that only we can able to write a logic, so that how much it can able to control the. So there are the design consideration of the battery. So at what rate meet energy balance requirement recommended rate by the manufacturer, charge it and discharge it. It should be. Apart from that, we have to basically in lithium ion battery we have to avoid overcharging. So protection for that, and what is the charging methodology for that. End of charge determined by the calculated rate, range in temperature, cell voltage limit, and the pressure of the each cell. So apart from that, trickle charging is required or not. This also taper charging is already there. So I will see that basically if you see any battery in the space, so we have to do taper charging only. It is charging by the solar panel. So for the first we are charging with a constant current, and after that with the constant voltage basically, and after that we start tapering. So each string we start tapering so that it can able to charge the complete battery. So this is the methodology it is used. But what is the limitation of the lithium battery basically? So it is highly intolerant to over voltage and deep discharge. So we have to protect from this. So these are the challenge. Apart from that, overcharging, over discharging, short and low temperature results in abuse and damage. Even the charging scheme and cell balancing in the battery is challenging, because of that only BMS is coming in the picture. So people are doing a lot of research on BMS, how to manage it. Apart from that, bypass electronics need to be taken care of open mode failure, and voltage immediate discharge needed to avoid irreversible damage to the cell. The next, the power stem electronics. So different methodology are like DET and the MPPT. But I told, so direct energy transfer is what it means. So in this solar panel and battery are directly connected. So so if you can see this figure, just I will go back and I will again come back. So this is the architecture satellite bus. So you can see this is the solar panel. In this battery directly connected to the bus. So whatever the voltage of the battery will regulate the complete voltage of the power bus. As the voltage battery is the voltage source, while solar panel is the current source. So whatever the power current required by the load, so it will be supported by the solar panel. So this design basically is the direct energy transfer. I will go back. So in this solar panel is directly connected. So I already told. So the bus voltage is same as battery voltage, and the solar array operating body depend on the battery voltage. This is used in most of the ISRO satellites. It is the most robust and simple configuration basically, and in this we need not to do any optimization. So it will the one demerit is that we are not using the solar panel at the optimized value, but it is the most robust method because we didn't need any DC in between, and there is no logic required. So it is failure chance is less in this. So in this there is sun regulated bus. In this we can see that PV array has shunt regulator. So it will but if PV array is having less voltage also, it can regulate to the required voltage which is required to charge the battery. Uh, discharge of the battery is like unregulated only. So if you see the fully regulated, both the things is taken care. Even the charging and discharging both are taken care by the regulators. Coming to the next MPPT, so I think everybody in the conference will be knowing about the MPPT. So in this solar array voltage always maintained at the maximum power point. So the full utilization of the solar array. So the different methodology to do the MPPT. Perturb and observe method is one of the methods people are using that to do the MPPT. We have a comparison of DET and MPPT. So, but pros are like that it is a very high drive and transfer efficiency, and but logic-wise it's very easy in the DET. But MPPT we have to write extra logic and extra regulators coming to the picture. So it's more complex and so coming to the next. This is the architecture of the satellite bus. So I want to explain first. So these are the solar panel which is highlighted. So you can see that each solar cell is having the bypass diode. Let's suppose one of the solar cell is got damaged. So it can bypass through this. So my chain is not discontinued. Even one cell is got damaged also, still my string will work. And this is the protection. For protection, we are using the blocking diodes at the string level. And this is a switch. So this switch will, based on the battery charge and discharge, it can give the command so to shunt that. So it can shunt. So it cannot overcharge the battery. So you can see that battery directly connected to the bus. So it is a direct energy transfer bus, and different loads are connected through some relay or some circuit through the fuses. So this is the architecture of the satellite bus generally used. Coming to power system electronics, what is the function? What it consists of? Basically, it consists of solar regulator, battery charge discharge control, bus protection circuit, power distribution, DC-DC converters, health status monitoring, subsystem on-off control, and remote on-off control. So there are two type of power system. One is a centralized, and other is a decentralized power system. Centralized by name only you can know. So one converter and through switches we can give, giving the power to the different subsystems. This is mostly used in the nano satellites. Decentralized power system are used in the big satellites because the one the below one is used in the big satellites because each is having the different isolated converters and each is having the one different relay or switches to give the supply to the different loads. I've not seen come across anything that in which it is used, second one, but this is also the decentralized power system only. So I'm concluding this. I want to say that if we shifted from nickel hydrogen battery to lithium ion battery, silicon solar cell to now multi-junction solar cells, chemical cluster to now we are moving to the electrical propulsions, and small tanks to larger power. So if it is a more power, more payload, and more capability. So thank you.
Thank you so much, Mr. Kumar Wilson, for this valuable knowledge. We hope to get more such acknowledgements from your side in the future. With this, we conclude today's session. We want to show our heartfelt gratitude to Professor Deepak Bansal sir for attending today's session as the chairperson. Thank you, Sitaram sir, for your presence. We thank all the participants for their presentations and all the faculty members for the smooth commencement of this.
Question audience.
Any questions?
Mr. SM.
Yes, sir.
Okay, the solar panel which you are using for solar satellite system now, the voltage level that I saw, that was 2.7 volt open circuit voltage.
Yes, sir.
So how much seriously we are connecting those solar panels?
Sir, actually,
I
we are
mean
not
to say, what is the output voltage of the solar panel in satellite solar system? What is the output voltage of the solar panel?
Sir, actually, what we have to consider, we are not considering the open circuit voltage first of all. We are considering the BMP, maximum power, maximum voltage. Also, if you see the, I will just show the. It is
I just
nearly
need to know the.
2.4
I just
volt.
need to
2.4 volts, sir.
2.4 volt,
2.4
and how much seriously we are connecting? I need to know the output voltage from the solar panel, just output voltage from the solar panel.
Sir, because solar cell is the current source, so whatever the battery voltage, I'm told that we are using the DET configuration, direct energy transfer configuration. So if so, basically, let's suppose my battery voltage is 32 volt. So we have to consider, we have to put number of solar cell in series such so much it can able to charge the battery.
It should be
So
32
let's go
volt.
32 is my
In direct,
32
direct
is the
energy
battery
transfer.
voltage. Yeah. So
32.
apart from that, we have to consider the voltage drop and the line drop, diode drop. So nearly 2 volt you take that. So it will become 34. So my solar cell should be such that, considering that it can go up to maximum up to 80 degrees Celsius, let's suppose. Because temperature also, with temperature, my voltage will change. So if you see the it's 6.4 millivolt per degree Celsius is the decrease in the temperature in the voltage. So let's suppose my 25 degree to 80 degree, if my voltage changes, so my voltage, my solar cell voltage instead of 2.4 volt, it becomes 2.1 or 2.2 only. Apart from that, we have to also consider radiation. That is 3% loss. And again, we have to consider the degradation, because with the time it should there is losses in the we can't perform 100%. So 3% to 5% loss is there in that also. So nearly I can't exactly, it is not 2 also. It will be nearly 1.9 per cell only. It is going to contribute for one cell. So based on that, you can calculate like 34 volt divided by 1.9 will give the number of cell in series.
Okay. Oh, the voltage level of the loads which we are
Voltage
using.
level of the loads. Let's suppose, sir, my actually I have designed for 28 volt bus. Let's suppose. So my battery will be 28 volt only. With the change in the battery voltage, my voltage variation will be there. Nearly 4 volt variation.
Okay.
So
I just need to know that all the loads that we are using in the satellite power system are at the same voltage level. So we
sir.
don't need
Actually, you have to use DC-DC converter for that. It can't be of the same. So DC-DC converter are used at every places. So that some are 5 volts.
The decentralized one that you were talking about. The decentralized
Yes.
For different
Even in
loads
the centralized also, if it's centralized also, like we can't have like if you want to use FPGA, so 3.3 volt and 1.5 volt is required. It can't be 28 volt or something like that.
Okay. 3.3 volt to light up the
1.5 volt, like in FPGA. In any FPGA if you used, it will be 3.3 to 1.5 volt only.
Okay,
Yes, sir. So there's a lot of voltage changes. I have just shown the glimpse. I'm not going into depth. So
Okay. Can you just tell me the present switching frequency that we are using to drive the switch in the power converter, DC-DC converter?
500 kilohertz. 500 kilohertz.
500 kilohertz. Okay.
What type of converter you have used? DC to DC converter?
Sir, mostly we are using forward converters.
Forward.
Yeah. Isolated. Basically, it is isolated you are using, so that's why.
That is the isolated converter, no forward converter.
Yeah, isolated only.
The transformer will increase the size of the system. Is it so? The transformer which will be using the forward converter.
In the big satellite, we need isolation because if you see RF system are also there. So because of that, we have to use isolation. So we are going for
the non-isolated converter won't be working in this system then.
Sir, if you want to go for the nano satellite, in that we are using non-isolated only. So like mostly buck we are using.
Okay.
In the nanosatellite also we have flown. So there we have used completely buck converter only.
Okay.
One
Okay.
place is boost, other place buck only.
Just I'm asking, a lot of research is going on the couple inductors also, na? Couple inductors.
Yeah. Correct, sir.
So instead of that transformer, that generally reduces the sizes. Sizes will be definitely a constraint for the satellite power system. That's why
Correct.
we are going up to 500 kilowatts.
Correct.
Okay. So is it so that multi-input DC-DC converter has been used in this system? Multi-input DC-DC converter.
That is not used, but I am working on that.
You are working with the same. Okay. Okay. ठीक है. ठीक है. Thank you.
Thank you, sir.
Thank you, sir, for your valuable talk.
Okay, sir. Shall I lead, sir?
Yeah. Thank you so much.
Yeah. Okay. Thank you, sir. Thank you to all of you, sir. Thank you.
Thanks to all the audience for